Hello everybody, I hope you are fine. In this video I'm going to specify the same two-factor CFA model that I specified in the previous video, but this time I'm going to do this using the interactive method. I will also estimate this two-factor CFA model using the PLSe2 estimator, and I will compare the results across PLSe2 and maximum likelihood. So as you can remember, we have this two-factor CFA model. Factor 1 is interpersonal conflict with 4 items, and factor 2 is role conflict with 3 items, and the factors are correlated. Just bear in mind that obtaining PLSe2 results is very simple. What you need to do is to specify your model in the usual way. You can, for example, estimate your model based on maximum likelihood methodology, and then at the end of the analysis you will have your EQS file. Then you can simply modify your EQS file to obtain the PLSe2 results. So what you need to do is to change the maximum likelihood, for example, to PLSe2 for the method under specifications paragraph, and also you need to add one extra paragraph which is technical, and under technical you have to add this statement: start is equal to PLS. Okay, now let's go to EQS to build the model based on the interactive method, and then we will estimate the model based on maximum likelihood, and then at the last stage, as I just mentioned, we modify the EQS file to obtain the PLSe2 results. I will also compare the results across the maximum likelihood and PLSe2 methodologies. Okay, first let me open my data file. So this is my data file. Alright. To build the model based on the interactive method, what I need to do is to click on Build EQS menu and then select Title Specifications. And since I know that my data are multivariate non-normal, I just click on this option so that the robust statistics are displayed in my output. Then I click OK. Now again I click on the same menu, and this time I select Equations. Basically I know that I'm going to specify a two-factor CFA model, so the number of the factors is 2. I also don't need all of the variables in my data set to be included in my two-factor CFA model, so I deselect this option. Then I click OK, and here I can select the variables to be added to my model. So let me just scroll down. I need IC1, IC2, IC3, IC4, RC1, RC2, and RC3. Then I click on this button, and then I click on OK. I click on Yes, and now here I have to define which item belongs to which factor and which factor loading is estimated. So for factor 1, I select IC1, IC2, IC3, and IC4. So the first factor, or F1, will be interpersonal conflict. Note that because of these asterisks, all of the factor loadings will be estimated. And for factor 2, I select RC1, RC2, and RC3. So all of these factor loadings for RC1 to RC3 will be estimated because I have asterisks here. Then I click OK. And now here you can see the variances and the covariances between the factors and residuals. So by default, you can see that all of the variances will be estimated, but remember I don't have any scaling items, so certainly the variance for F1 and F2 must be fixed to 1 because I don't have any scaling item in those factors. Also I need factor 1 and factor 2 to be correlated, so I click on this cell so that this asterisk appears here, which means that the covariance between F1 and F2 will be estimated. Then I click OK, and now you can see that all of the equations, variances, and the covariances are displayed here. So for factor 1, I have these 4 equations. You can see that all of the factor loadings are estimated because I have asterisks here. And for factor 2, I have 3 items, and all of the factor loadings are estimated. Also the variance of F1 and F2 are fixed to 1. The variances of the residuals are estimated. Also the covariance between F1 and F2 is estimated as well. So what I need to do is to save this model. I just save it as model 1. Alright, and now I can simply run this model. So this is the results report, and it is exactly the same as the results that we had in our previous video. So I'm not going to explore these results. It is exactly the same as I mentioned. What I'm going to do is that I'm going to close this and also close this EQX file and also my data file. Now I'm going to open my EQS file. So here you could see that in this folder, in the folder for this example, I have one EQS file. I just open it, and this is exactly the file that I ran to get the results based on maximum likelihood and robust maximum likelihood methodologies. So if I want to obtain the results based on PLSe2, what I need to do is to change ML to PLSe2. Also, I need to add one paragraph here, which is technical. Alright, then start is equal to PLS. Alright, now I just save this as a new EQS file, model 1 PLSe2. Alright, save. And now if I run this model, I will get the results based on PLSe2 methodology. So let me just scroll down. You could see that we have no problem in this analysis. And here you could see that we have the goodness of fit based on PLSe2 methodology, but remember our data are multivariate non-normal. So what we are going to do is to focus on the results based on the robust method or robust PLSe2 methodology. And here you can see that we have these VGDs based on the robust methodology. Alright, we have all of those factor loadings. You can see the standardized factor loadings here, and the R-square values as well. We can see the variances that have been estimated based on PLSe2 methodology, and all of the robust standard errors and Z statistics. All of the variances are statistically significant. All of the factor loadings are also statistically significant. Here we have the covariance and also the correlation between the two factors, 0.538, and basically it is statistically significant. We also have the standardized solution here, and we have this correlation between the two factors. So this is the results based on PLSe2. Now let me just open the results based on maximum likelihood. So this is the results based on maximum likelihood. If you can see here, we have method is equal to ML. So I just scroll down so that you can compare the factor loadings based on these two methodologies. So here, the first factor loading for based on PLSe2 is 0.632. Here we have 0.602 for ML. For PLSe2, the second factor loading, the factor loading for IC2 is 0.677. Here we have 0.687. We have 0.836 here. We have 0.850. And basically you can see that these values, the factor loadings, are quite similar. With respect to the correlation between the two factors here based on the PLSe2 method, you could see that the correlation between the two factors is 0.538. Here we have 0.487. Let's have a look at the robust fit indices, because our data are multivariate non-normal. So NFI for based on PLSe2, which is 0.931. Here we have 0.953. For NNFI, we have 0.892. Here we have 0.928. And for CFI, we have 0.933. Here we have 0.956. For IFI based on PLSe2 we have 0.933. Here again we have 0.956, and MFI, which is the McDonald's fit index, is 0.923 here, and based on ML this value is 0.948, and RMSE value, the robust RMSE value is here 0.111 based on PLSe2, and based on ML it is 0.090. So these are the robust fit indices based on PLSe2 and also based on maximum likelihood methodology. Here in terms of the iterations, you can also compare the results. Based on PLSe2 it only took 6 iterations for the model to converge, and here the convergence occurred in 5 iterations based on maximum likelihood. Okay, it was all I wanted to share with you in terms of specifying and estimating a two-factor CFA model based on PLSe2 estimator. We also compared the results across PLSe2 and maximum likelihood, and I hope you enjoyed this video. Thank you very much for watching.